How about now? It's picking me up now, I think.
Okay, and the sound?
Cool, cheers guys. That's a start, now keep going. Is that?
Okay, and the sound good.
Oh, we're on Facebook, so that's good. There's that one.
Yeah. How about this? Is that? How's that, guys? Have we got something like it now? A bit of sound happening? Is it working on yours?
Sound is much too low.
Much too low. Right.
So we've got to project better.
Better now. Great.
Very good.
Right.
Good.
Getting there.
Here we go.
That looks good.
Lovely. Cheers, guys. Thank you for the feedback. Right, should we try again? And so, thank you all for joining us. That's brilliant. Appreciate that. You may or may not have seen our video presentations, which came out on Monday. Obviously, we did a practical Pico session and looked at physical testing of the physical layer, and Stevie here did a great job of the serial decoding.
I'm not so sure about that. If you did stick with that, thank you so much. There was a lot going on in that video. Serial decoding, hopefully it'll show you or demonstrate you the limitations within Pico as a serial decoder, but it is there, it's a tool you can use. So any feedback you've got on that would be really appreciated, or anything else you'd like to see within that decoder.
Yeah. So essentially, we've got Ben's we're all okay with CAN. We're all good with CAN. But Ben's our expert on J1939 and the plant and heavy machinery, as well as your day-to-day automotive stuff. Steve, as you've seen, is our serial decoding guru.
And we are not working.
Yeah.
No pressure there, I'm sure. Yeah, yeah.
And I'll try and chip in where I can.
Yeah. Set the cleverest man in the world.
Exactly. That's not, a man had to set this up somehow.
Yeah.
We wouldn't be here now if it wasn't for him.
Yeah, very true.
So we've got, so too much light. Yeah, thanks, Diagnosed Dan. We're very blessed with this workshop. As you can see, we've got...
The light is overkill by the sound of it, right?
Yeah. If anyone's got any specific questions that you want to ask, then just fire away by live chat. We will do everything we can to get you an answer. Otherwise, we'll maybe get back to you another time. You can always email us at support@picotech.com. Failing that, have a look on the website. Dig around. There's always
anything. Also on the forum, Barney mentioned support at PicoScope, but the forum as well, Pico Auto Forum, so much going on there. Any thoughts, share them on the forum, any concerns on the forum. What I really like about the forum is just how open it is for everybody to see and for everybody to chip in, because we've all got an opinion, and everyone's opinion is right, of course, but it's always good to be challenged on everything that we do.
Well, we've got a lovely challenge here, Steve.
Yeah.
What's the failure threshold of a CAN signal?
What's the failure threshold of a CAN signal in terms of, would that be voltage threshold? Would that be failure threshold of a CAN signal?
It's ultimately, in the first sense, it's whether an ECU who knows that it needs to receive a signal can actually interpret the signal, so it'll check the payload of the signal and calculate a checksum from the message it's received. If that checksum equates to the checksum that's been transmitted with the signal, then it knows it's okay. So fundamentally, you've got that to check, and if that doesn't work out, then they will complain. And voltage level wise,
yeah, I've just seen that. Thanks for clearing that. The voltage level. That's a question that I don't know the answer to. If we look at our decoder, we always set our decoder crossing point, because I think that's what you're referring to, the transitional point would be 1 volt, because we are decoding on the maths A minus B, 0.2 volt. So it's a question. What I'll do, I will mark that down. I'll find out exactly what the threshold is, voltage-wise, And also, perhaps in addition to that, would be the timing. How far along does it start to count as 1 bit? We know that 1 bit on high-speed CAN is 2 microseconds, but does it allow for an edge either side? So it's something I will look into, and I can post that on the auto forum if that's where we could clear that up, or email direct at Science of Diagnostics.
He was a very active participant on our Practical Pico premiere on Monday, so I appreciate that. Thank you for your questions there as well. Yeah, please keep them coming.
By the way, I have to write this down because I will forget.
Yeah.
It's
an age thing.
Is it an age thing? I'm not sure. Yeah. You speak for yourself, Barney. Speak for yourself.
Okay,
sure.
Next one in.
Single wire modes are priorities of the network changed. In single wire mode, do the priorities of the network change to allow less of the modules to speak? So single wire mode, I'm thinking here of convenience CAN on VAG vehicles, where the CAN can actually work in single wire mode. Is that what we're referring to? Because single wire mode has no effect at all on CAN messaging. So should CAN low go down to ground, it will switch to single wire mode and transmit exactly the same, with everybody having the same priority, still following the same protocol. So nothing suffers as a result with VAG convenience CAN once it goes into single wire mode.
No, it should be a broadcast network, shouldn't it?
Yes.
So everyone that has access to it should just continue to do their thing.
Yeah, that's a good question.
Brilliant.
Yeah. Okay. So convenience CAN.
Yeah.
That's something we are presenting on later this year, also in Inform. So in April of this year, we're doing a convenience CAN and powertrain CAN, combining the two because they're quite unique in the way they work in their voltage thresholds, but also, as you clearly mentioned there, when they go to single wire mode.
Yeah. Okay. Single wire mode.
Diggers, Ben, this is for you.
Oh, diggers. Oh, here we go. Hello, Neil. Yes, okay, so MCU failure had a signature CAN waveform with noise interference. It's purely plant machine, I would like to see what's made. I think, Neil, it is more generally, in my experience, more with plant and agricultural and off-road machinery, off-highway, sorry, I should say. I think vehicles, they seem to be a lot more, I don't know, well made, I think is the word.
Less noisy.
Or less noisy, yeah. I think with the big machinery, they do tend to have lots of metal, and that, you know, that will cause issues, especially at ground levels as well. So I think they're made to accept a higher level of tolerance than vehicle manufacturers from the automotive sector. So it's just a very interesting part. It's not something, as well, in my experience, I've not really looked at too much, and it's only having been with Pico have I been given the opportunity to go out and look at this in more depth. So it's all still quite new, but yeah, it does seem to be that the interference on diggers and plant and agriculture is more noisy. Yeah.
Sorry, Barney, if I could just pick up on that one about the digger. A lot of what...
Well,
sorry.
I just realised, fundamental mistake. I should explain to you guys that we're doing simultaneous live broadcast on YouTube and Facebook. So if you're on Facebook and wondering what on earth we're talking about, we've got questions on YouTube so we're keeping track of both sets of questions. So the question is about a digger MCU failure, and which had a signature CAN waveform with noise interference. And is that something that's typical of heavy plant and machinery? And so this is the response that these guys gave. So
yeah, I wanted to pick up on a point that Ben raised, and that is a lot of the waveforms that Ben's brought back from agriculture are being not alarmed, but automotive light vehicle CAN. You see that wonderful threshold recessive voltage 2.5 volt. With diggers, that quite often wanders high and low, and quite often drifts as well. Almost you end up with a CAN waveform that looks like this as it's recessive voltage. Nevertheless, when you do that A minus B, you end up with the true 0.2 volt. So, yeah, CAN is incredibly fault tolerant.
Yeah, and it does still decode really nicely. So it's not like you could almost be misled slightly, but using the maths channels actually does help clear that up, definitely.
Yeah.
So we've lost our comments.
Yeah. It's not. Is that under the comment? Will that click on it? It won't take anywhere if you click on that with it.
Exactly diagnosed, Dan, yeah.
Diagnosed, Dan. The comment is, like in Italian cars, well, couldn't possibly comment.
So the next question, do we have reference waveforms for distorted CAN signals? For example, shorted to ground?
Yes.
Hi John, well we made an attempt to make some of those reference waveforms for you guys in the practical Pico video. So I think it's about from 10 to 15 minutes into the video, we run through a series of examples where we consecutively look at shorts, and then we look at some open circuits and missing termination resistors, and at the very end we look at a high resistance. So there's a kind of a nice sequence in there which will show you what will happen in those different conditions. One thing that comes out of it is measurement location, and also the difference having a termination resistor can make to whether you see a voltage on one or the other lines depending on which is shorted. So definitely have a look at the practical Pico video. I think again, as I said, it's about 10 to 15 minutes in that section of the video, and there's a few little nice waveforms there. Failing that, of course, there's always the waveform library. If you guys could upload any reference waveforms to that, we would really be very grateful and benefit everyone.
There's a couple of forum posts regarding CAN and just how fault tolerant CAN is. I mentioned fault tolerant earlier. There's some interesting ones where we've given an example of a CAN that looks totally and utterly distorted, yet once again doing the maths you can see that you can still decode. So as you mentioned there, distorted CAN signals, shorted to ground videos, we've got that covered in those videos. Science and Diagnostics mentioned the serial decoder. Have you run the decoder where a termination resistor is moved? Yeah. It's almost business as usual with one termination resistor missing, as you got in the BMW. We were quite surprised how little effect it had initially. Bear in mind was engine running?
We actually only had the ignition on, but even then it didn't make a huge difference.
I guess perhaps the more we load the bus, we might see the threshold start to rise up or even flutter. But again, CAN will tolerate that quite comfortably.
Yeah. Yeah, it was. You could see a little bit of ringing in the signal and that type of thing, but it wasn't excessive, surprisingly. Obviously, that may change from vehicle to vehicle, and the degree of sort of noise isolation they have, and so on. Yeah. And what else we got?
Yeah, just grab a rental vehicle and scan it all and break things. Yeah, to do your own database research. Yeah. Okay.
Yeah.
It works. It works.
Cool. What else? That's the case.
Yeah, trying to watch two screens at the same time is interesting, isn't it?
Sorry, guys. Yeah.
You are watching us watching you.
Yeah.
Sorry, guys.
Happy days. Yeah.
Good stuff.
Steve, were you? Is there anything you wanted to add about the serial decoding and maybe the diagnostic value in that? Because I think there are some questions after the practical Pico. There were certainly a couple of good examples Steve showed.
This was trying to use serial decoding to understand who was online. So we look at the CAN IDs, and that's all we face with. How do we try and prove who's online, or whether we can try and decipher what those IDs mean? So I looked at disconnecting different nodes, different computers, and using Excel to try and make life easy. So rather than search through every single ID, you could find the missing IDs quite quickly. I didn't demonstrate it in the video, but it's in the forum post, and that is using a current clamp. This is quite intriguing, but it works really well, and this is placing a current clamp around a single CAN wire from a computer, forcing the computer to produce an output. For example, if it's the ABS, for example, press the brake pedal, and watch the current from the CAN network from the ABS ECU. So you need to try and work out which message it is using the techniques we demonstrated, but it's another pointer towards the ID matching the computer that you're working with. I hope that makes sense. It sounded a little bit clunky, but it's... the example I used was a BMW shift lever. So I would select park, so I forced an output from the shift lever, and I captured that event in the decoder, but I could also see when that message was transmitted how the current momentarily rised in the CAN network, so I knew that that ID came from the shift lever.
Okay.
Yeah.
Cool. Yeah.
There's a number of ways.
Yeah. The other nice test which I've used in the past, which has diagnostic value, where, for example, you've got a message which needs to transfer from one network to another via gateway, and you can track, particularly if there's two systems which need to know about each other. So I'm thinking here, central electronics and engine ECU for immobiliser via a dash cluster, and you can use the serial decoding to identify the request for the immobilisation from the central electronics. So it's coming from the powertrain control module to the central electronics and back again, and it'll ask it twice. And I've had a problem before where the ECU, the engine ECU, was asking for the go, and for whatever reason it wasn't happening, even though the central electronics said the key was okay and the engine control module was asking the question okay, and it turned out there was a breakdown in the network, but there were no CAN faults in that vehicle. So that and what it turned out was actually the central electronics module wasn't returning okay on the second request, so it asked twice. And the only way you could diagnose that fault is by actually doing serial decoding. As I say, the networks themselves were fine. It was the central electronics module which, for whatever reason, wasn't sending out the second message. So yes, it does have that diagnostic value as well.
I think that almost follows on to what I think New Leather Auto, I think that's what you was alluding to, I think there, isn't it? It's where we've got an ECU which is, I know it's, just put it here.
Might have scrolled up.
It might have scrolled up, just bear with us. One thing you never want to see in real life, where one module alone will respond to being CAN high and CAN low shorted to one another. Mm-hmm. So if it's an internal fault, then I guess that ECU would be offline to a degree, yeah. But it would actually have no real effect on the network. Yeah. So how would we? Well, I guess, like you said, it's in that way you probably have a fault code, I imagine, that would start pointing you in the right direction. Yeah. Maybe.
But is it short in the network CAN high and to CAN low, or is it just internal within the ECU but not on the network?
Okay, yes. So Science Diagnostics has said so this type of fault can be within the circuitry of the transceiver. So that's the
circuit within the module, but not bring down the rest of the network. Yeah. Okay, so that would be missing IDs associated with that controller, fault codes as well. Yeah. Okay. Or from other controllers, lost communication with that controller. Yeah. Okay. Great. There was a question there from Steve Jacobson, and that was, why won't you see current from the other signals? This is when you're measuring current in the CAN circuit. So with the BMW shift lever, I was on the CAN wires direct coming from that shift lever. So I forced an output from the CAN controller that placed a message on the network. So my current clamp is around a single wire from the shift lever assembly, shift lever ECU. So I would see the transmission from there. Other activity, I can't remember what other activity you see, but you can clearly link a rise and falling current directly above that message when you've placed your current clamp and your serial decoding together in PicoScope. I'm not sure if we can get the link for that, so we can post the link on here, but you'll see that actually in action. Or if you search for, on the Pico Auto forums, who's online, who said what, that was the forum.
Here we go.
post.
Yeah, I can, no, sorry. I tried to do that.
I'll see if I see if I can add them in, guys, into the chat that's going on at the moment.
Cheers, Ben. That'd be
Thanks,
great.
Ben.
Thank you.
Yeah.
Okay. Yeah, all right. Yes, thanks, Diagnosed Dan. Ben will bring that up for you and plonk it into the two chats for us.
Sure.
Some questions on Facebook about merchandise. Yeah, that's one for the company.
Yeah. Slightly above our pay grade.
Yeah. So.
That easy indeed offline for coders would have you thinking the problem is all about the whole network. Okay,
Yeah.
Thank you.
That's
Yeah.
interesting. Yes.
I've used canvas decoding to detect error frames as well as to force inputs into a module to elicit a response. Yeah. Science of Diagnostics, Michael, I've used CAN bus decoding to detect error frames as well as to force inputs into a module to elicit a response. It's a relatively new testing method, so it's clunky, but it has potential. I think you bang on the money there, most certainly. So you're placing a message on the network, is that correct? Force inputs into the module. It's a relatively new system. Decoding to detect error frames as well as to force input. So you are actually creating a message and placing that onto the network. So you're doing that with a decode tool of some description, I would take. Yeah. It would imagine.
That would have to be a dedicated.
That would be a
tool.
dedicated CAN tool. Yeah. We touch upon it a little bit in this forum post that Ben's putting on there, where you use the standardised scan tool, OBD for example, to send a request out and force a response back from engine ECU. And if the manufacturer is allowed, you can also send some standardised codes out to things like transmission ECU, and you get a standardised response back. I can't remember what they were. I think it was 7DF was for.
Sounds about right. Yeah.
7DF was for engine management, and you got back 7, 8, E8 or something like that.
Yes.
And in the specifications for CAN, and this is only if the vehicle manufacturer allows you to do this, you can send out these standard requests and have answers back from instrumentation, ADS, transmission control, and engine management. What you're doing there is actually creating a message, placing it on the network, and requesting a response from another computer. It's a great technique, a very advanced technique as well.
Yeah. Yes, in that case, the OBD codes are a fair bit more standardised, so you'll probably have more joy doing that on an engine control module than other modules. Yes, that is a sort of a nice little rabbit hole to disappear down into.
I spent a good couple of days there as well.
Yeah, Steve, I get that as well. I saw that. I just don't see why one message shows up on current while others don't. Yeah, I guess we've got to think about where we're measuring from the point on the network. We're on a branch wire rather than on the loop, if you like. So if you think about the shift lever being on the CAN network but branched off, and I've got my current clamp around a branched wire coming from the shift lever, I know that it's going to send the parking message because I've managed to decipher that in the decode. And clear enough, there's a rising current at the moment the park message is sent. So I was happy that when you look at the timing as well, the timing of the current, the timing of the transmission, I'm happy that we've proven that concept.
So essentially you're saying that the voltage you
drive,
that's
yeah.
right, it is different. Your current gives you something different than voltage, basically.
Yes.
That's what Steve's telling you. So, yes, if you were to look at the voltage in the lines, they would be the same everywhere.
Yeah, of course.
Current is different.
Yeah, depending on where you measure it in the circuit. Yeah. If you were trying to do that on a network wire, perhaps that was in the sill, that was part of the bus loop. you couldn't see it there. You're absolutely right.
What else have we got? So you've seen the forum posts hopefully there. There's loads on the forum that Steve's put on there.
Yeah,
to see.
there's a lot of real life faults shared on the forum as well. So guys, you've posted things on there, you've shared CAN waveforms. Some great feedback from technicians. It's on the forum. What's great about the forum is technicians supporting technicians,
Yeah.
and where we can, we put our 2 penneth worth in. And yeah, we learn from you guys. Believe me, my gosh, the forum is it makes for considerable reading. Yeah.
Again, another rabbit hole you could disappear into for a good few days.
Steve, a quick about the K110 clamp. That's the milliamps clamp that you're going to use. That is a very good clamp, but it's very low bandwidth. So my first attempt at measuring the current from the shift lever on the CAN network showed the peak of the current not long after, but a considerable way after the message was transmitted, because the bandwidth, the response of the clamp was 5 kilohertz. I think we're on 20 kilohertz. No, 500 kilohertz high-speed network CAN. So I actually used the Pico 30 amp clamp with a lot of filtering. Yeah, and I could see it. The clamp that I've used in that forum post is the Pico 30 amp clamp, which I've got one right here.
Yeah.
Oh no, here's what he made earlier.
Yeah, that was this clamp here. So whilst that 10 milliamps, I believe, is the limit on that, with filtering and scaling within the PicoScope software, it was clear to see a response. So yeah, it needs work in the software, but you can do it.
Yes, got a question here. Is serial decoder usable for flex ray?
Oh, great question. Yes.
Just trying to find the link.
Yeah.
I'm just trying to find the link on it.
There is a forum post. Unfortunately, the forum post reveals a problem with the serial decoder within FlexRay. So a question was raised on the forum about I think it's the TA375 high impedance probe, because you wouldn't use standard test leads on FlexRay. And that was, what's the difference? And I've put a forum post together where you can see conventional test leads against the high impedance leads. I've then tried to run the decoder, and the decoder didn't work on that data. So that has gone through as a bug. I need to check on that. So I will follow up on that on the forum post.
Yeah. Yep. Thanks for that, though.
So the FlexRay decoder. Thank you.
How much current in milliamps? So the question was, how much current did Steve measure when he was looking at his transmission control module CAN bus branch?
I'd have to look at the forum post. I think it was between 5 and 15 milliamp. It was tiny. Yeah.
It's another question. Measuring current to identify the module. Is any?
Oh, that's tough, isn't it? I think with I've done it a little bit with smaller networks where you can, say for instance, my own Mazda's got a very small little network which only has about 3 ECUs on it for the infotainment system. When you're dealing with that, the small number of ECUs, you could quickly disconnect one and see the current drop away from a particular ID, but it's not easy on the bigger ones. I think you're going to be dealing with a lot more.
It's an experimental technique.
Yeah.
I think. But could get you out of a hole. You never know.
Have a look at that forum post with the shift lever, because I placed a button on top of the shift lever, so I know the point where I was pressing the button down, so I know where to look in the stream of CAN data. And then when I also see the current rise up next to it, it was a win-win. You could see that was the message transmitted from the shift lever when the park switch was pressed.
Yeah. What else have we got?
Measuring the current modules, is there any mileage in clamping the live feed to the unit instead? That's a great question, Matt. Thank you. Is there any mileage in clamping the live feed to the unit instead? So think about the power supply to the CAN module, the ECU. I'm not sure we pick up the message amongst other activity, other current flowing to that ECU. If you think about the power supply to an engine management ECU, that will be busy supplying and grounding other components, as well as providing the drive or the power supply for the CAN controller, which voltage would be stepped down anyway to 5. So I'm not sure, Matt, on that one. It's a technique worth trying, definitely, but I'm not sure whether we'd see that.
Another one here from Science of Diagnostics. Where do we see serial decoding going in the future? That's a good question. I think can reiterate, whilst these guys think about that, I think we can sort of
some time.
I kind of reiterate. I think the sort of 3 initial techniques that come to mind are the ECU identification, what's there, what isn't, and looking at their different IDs. There are the circumstances. There's one Steve showed in the Practical Pico, where you can actually look at specific messages, and certainly in simple cases where you've got a binary type yes/no signal or on/off signal, you can look at whether you're, so for example, pressing the brake pedal, your ABS units will pick that up and send that message out to the other control units, and you'll see one number changing when you zoom in with a triggered signal. It's in Practical Pico, it's all there. And so you can see that activity, so you know that message is being sent. So that's 2, and the third is the other one I mentioned, where you're tracking messages from one network through a gateway and possibly other control units. So the gateways aren't just ECUs acting as gateways between low and high speed networks. You also have other ECUs which loop through, basically a single network will loop through it, for example a high speed network, and sometimes that may interfere with the messages. So tracking the messaging. So certainly those 3 methods are legitimate use cases for the serial decoding tool. Yes, another applications, it depends how far you want to go and how much you want to develop your experience. You can obviously start to try and decode J1939 data, or yes, or if you really want to have a go, you can then start on the manufacturer sort of proprietary data, if you like, and diagnostic data, for example. It's worth having a look at and playing and getting used to that type thing.
I think if I can add a little bit there, remember that the PicoScope is not a data logger for CAN. You're quite limited in the amount of buffers that you've got to work with, so you'll get a very small snapshot of CAN. I think we worked it out to about 8 seconds of CAN data with the settings that we've got in the videos. What I would like to see would be the graphing of CAN data. So let's say we've pulled out a message from a particular control unit and we know what that is. Wouldn't it be great to be able to graph the CAN data alongside data in the time domain? So looking at live values direct on the wire, and then having a look at how that's being interpreted by the ECU and transmitted on the network. Even simpler, perhaps something like engine management light on or off, to be able to graph that in serial decoding. That would be something. So we'd have a little icon that you'd know when the engine management light came on, because you've got that information from the CAN network, and then we could see in our time domain from our PicoScope data exactly what activity forced that light to go from off to on. That's what I'd like to see.
Right.
Nothing much.
Should we get on with it then?
Next week's update.
Right. Just going back to the question about the amount of current we measured diagnosed down. I've just scrolled back through to Steve's post, and it looks like it's about 37 milliamps.
Wow. Okay.
Yeah.
Thanks.
That's
I,
all right.
I was quite. I thought it was far less, but anyhow.
No, that's where it seems to be. Providing your current clamp is zero.
Correct. Yeah. Providing the current clamp
Providing
is
the
zero.
current clamp is zeroed, then yeah,
But
that's
there
what
again,
it's measured.
if it hadn't zero, what was it, Mark? 28 to 30?
26
to
26.
35. So say maybe 10 milliamps then, because he wasn't on zero, but we were using the current clamp not to measure current, but as an indication of a change of state of current.
Yeah.
So it's as a relative measurement, if you like.
Yeah, that's right. As you said, it's just can't respond fast enough to get accurate measures, but it is.
But it certainly responds
indication.
on time, on message.
Yeah, absolutely.
Transistor style terminating resistors.
Right, okay. Transistor style terminating resistors. So that would be.
Does that imply
for-
they're active?
Yeah, I guess so.
Yeah. I've personally not seen.
Is there more on that new level auto transistor style terminating resistors? Is that something you've seen, or is that something that's out there? Because it'd be great to look at that.
Yeah.
Active termination, yeah, where have you seen that? Yeah.
That would that be
Interesting. So termination resistors, as Keith mentioned. I don't know about that. So the science of diagnostics, can you touch on transistor style termination resistors, as Keith mentioned?
would it be a,
I don't know. I haven't come across that active termination.
would it be a, I mean, the use case that comes to mind would be flexible data rate type buses where you've got changes of bus speed, maybe.
Maybe.
But no,
I think
sounds exciting.
With CanFD, that is, for want of a better description, backward compatible. It'll run alongside conventional CAN, and at times switch to high-speed data, and then revert back, but still on a conventional CAN network. So, yeah, anything you've got on that would be good.
Yeah.
Something that's out there, it seems. I haven't experienced it yet. No. So it's something for the pad. Thank you. And transistor-style terminating resistors.
Yeah. Anything else you want to tell us about?
Be nice to get something on the forum about that. So if I do dig out something, can find the vehicle, can measure, and dig out the theory behind it, I will post it all on the forum. Seems Hyundai have adopted it. Thank you for that. Do you know the model on that one? So Hyundai have got this active termination.
Yeah, sorry, Facebook guys. We've got on YouTube here. There's a conversation going on about transistor-style terminating resistors. So presumably they're an active termination. So I can only imagine. And we've got a comment here saying that they're now being seen within multiple gateways, presumably within a system. It's something that Hyundai have adopted. So that's something we're going to look at because that's definitely interesting to us. So yeah, that's from a user called New Level Auto. So we appreciate that. Thanks, guys. And science of
It's using
diagnostics.
flexible networks. If a network may have varying numbers of modules, it is better than passive resistors. Okay, thanks for that. Science of diagnostics, it is used with flexible networks, so CanFD, where you can change the data rate from 500 kilobit per second to up to 1 meg, I believe, with flexible data. If a network may have varying number of modules, it is better than passive resistors. Okay, so we'll dig and delve into that one and definitely get something out there.
Yeah. No, we appreciate that because we will be looking at other types of networks later in the year, so we will dig into that and make sure we're a bit more scotched up on it.
So depending on which modules are fitted on a given network topology, it's easier to use active termination than it is to modify the location of passive resistors for proper network operation. Oh, God, okay.
Okay.
So really then, this sounds like it could change the location of termination resistors to minimise the effects of reflections in different parts of the network, maybe.
So presumably on different vehicle variants, so they can have, say, they can put the same topology basically throughout a set of vehicles, and then just change the coding, presumably, which will then change the active termination. So they only have to do coding changes across the ECUs to update their. I'm sorry, I'm making this up. That seems logical.
What about if it's more like, I'm thinking of Toyota now, where they changed the way that their network topology, if you like, it doesn't look like a conventional bus. So you have a gateway, and then multiple variant buses coming off of that one gateway. So could you use active terminator resistors instead of?
It seemed to pass between.
Exactly.
Okay, yeah.
I don't know.
Gosh, that's interesting. Yeah.
So maybe it's bus loading as well. Maybe at busy times, it might be better to have termination resistors in specific locations about the vehicle. And when bus loading drops to a certain level, and this is all hypothetical, it's thinking why you would use that. There's obviously benefits to it, and I'll get to that definitely.
Cool. A question there from John. Is K-line independent CAN? Yes, it is, John. Yeah, that's been answered there, so thanks, guys. It is, yes, as described, single wire, lower speed. New level auto, you're doing a storming job. Thank you. We'll tell you what we'll do. We'll turn the camera onto the screen.
We'll just
from behind. It's awesome. Thank you. Appreciate that.
And Science of Diagnostics, I'll send Ben an email. Thank you for that. That'd be great. That'd be really helpful. Appreciate that. We live and learn together, remember?
K-line was a popular thing, particularly in the VAG group. They used to do a lot of diagnostic communications on K-line and so on. Mercedes as well. Don't see it so much these days. So I wouldn't invest too much time in it unless it's catching you out on something else.
It's still out there, though.
It is still out
there.
there.
And you can diagnose it with Pico, of course.
Yeah. We've got, so we'll touch on these things later in the year, but in serial decoding we do have LIN-bus diagnostics, CAN, hopefully FlexRay back with us soon.
I need to look into that.
CAN FD is...
CAN FD is in there. It's in there,
Send in there.
I think Send is in there, so
Send is in there.
In actual fact, we can have a look. Let's have a look. Here we go, guys. Let's see what we've got. You should be seeing my screen. Now, tools, serial decoding, create. So CAN FD, FlexRay, LIN, Sent, fast and slow. It says a fair bit going on there. This, what you can see here now is stream ended.
Guys, if you're watching this through YouTube, could you just put a quick comment in the comments to say if you can actually see? We should have a picture of the PicoScope software, which Barney should be displaying on his screen. Could we just confirm that that is still there? The stream is not ended.
Okay, phew, thanks guys.
Brilliant. All right, thank you. Sorry, it completely changed on our one.
What's
going on?
Thank you, Drew's Auto there.
Perfect.
Multiple thumbs up. Thank you.
Bit of a sweat.
Excellent.
So, you couldn't see the drop-down menus. Okay, right. Sorry about that. That's a shame. Okay. Well, anyway, as described, there are tools. There are extra tools there.
Question from Vastech there, is there any way to see who is talking in the CAN network based on the readings from the current clamp? You couldn't pin it down. It depends, remember, where you place the current clamp. Again, coming back to the BMW, the current clamp was on the wire directly coming from the shift lever control module, branching down onto the CAN network. To be able to place a current clamp around a random bus wire, you will see activity of all sorts, current positive, current negative, but to determine who is sending that would be incredibly, you couldn't do that unless you use the technique on a specific module, forcing the module to announce or make a change to the network with a message.
Cool. Okay, thanks for the confirmations, guys, that we're still live and kicking, so to speak.
Still live and kicking.
Is
it getting that late?
Sorry.
There was a question from Mark that was raised yesterday because we discussed at length about CAN termination and the two 120 ohm resistors. And VAG in their powertrain CAN, they have quite a unique niche way of achieving that magic 60 ohms, and that is they have a single termination resistor in the powertrain, so the engine management ECU of about, he was turning to his laptop and now the screen says about 66 ohms. And then you have matching resistors in every other ECU on the network, and combined that then brings the resistance down to between, I think it's 56 and 60 something ohms. So you still get the magic 60 ohm value, but it's achieved differently. And that's unique to, or niche I should say, to the VAG brand.
Okay, cool. Thanks, Steve.
Yeah, thank you Mark Stammers for that, because if you are chasing that network resistance, you could well think you're onto something because you are not getting, or you've disconnected one control unit that was giving you the 60 ohms. You'd expect the network resistance to now go up to 120. Well, it wouldn't. Yeah. So you'd be chasing a fault that doesn't exist on that car.
Yeah. So is there any other sort of problems? We've done some fairly high level stuff here. So if there's anyone sort of in the background that is maybe feeling a bit intimidated or anything like that, please speak up. You know, there's as you can see, none of us know everything, that's for sure. We're all learning, so please feel free to bring anything up. Don't feel shy or anything like that.
Yeah. So I'd like to know the main difference between FlexRay and CAN bus network, and also does FlexRay, Ling, and MOS have terminating resistors?
Good question.
Very good question.
FlexRay.
MOS is fibre optic, yeah, exactly, diagnosed down. So the likelihood is they won't be having any terminating resistors. I wouldn't have thought so, because it's an optical network.
MOS in there?
Yeah.
Oh, okay. And
yeah.
MOS.
You've read that as most.
I read that as most. Yeah, I'm only human.
Oh, sorry.
Yeah.
Unless that isn't what was meant. So we might get that wrong.
My minimal understanding of FlexRay here is that CAN messages are broadcast on winning arbitration, the message highest priority. FlexRay, I believe, there's a time slot for your message to go out, and that's very loose understanding of FlexRay at this stage. Apart from that, it is 10 megabit per second as well, ultra high speed.
Yeah. So FlexRay, you've got fixed time slots to get your message in. It is absolutely fixed, sort of rigid, sort of just streams by and boom, there's a slot.
Where if with CAN, it's about winning the arbitration, the message with the highest ID. If you have lost arbitration, you will keep trying on the next starter frame to see if you can get your message through. Yeah, FlexRay different again to that.
So we've just had a clarification about most. It's not always an optical.
Not always optical. That's true. Yeah.
Thanks for that. Appreciate that. Yes, and say that there's different ways that the messages are structured. The reason they exist, that different types of networks exist, is primarily for different speeds and volumes of data. So most in FlexRay are designed for much higher volumes, perhaps entertainment buses and that type of thing, networks. Lin is a much lower speed network, single wire, and designed for convenience, so simple sort of on-off signals, that sort of thing. Then CAN, as we discussed, so it's down to kind of application more than anything, the different why they exist. Okay. So
data logger. Yeah. Okay. There are numerous loggers out there. I've used a couple of loggers, and I really like the way in which they present the data and the fact that you've got endless streams of data coming through. It gives you an opportunity to not highlight the limitations of Pico as a data logger or as a serial decoder. Remember, it's a tool that is capturing the data instantaneously, and you're limited to your amount of buffers.
Yeah.
It's a great advantage if you've got a CAN logger out there, or you can apply one with Pico in conjunction with Pico, then it's a win-win, that is, yeah.
So as Steve says, we can really, with Pico, you can really zoom in on single events and specific events, and you get an amazing detail that you wouldn't sort of get with the logger. They're obviously not designed to look at the actual physical signals, and also you can capture within a window very precisely with Pico. And the loggers, yeah, if you've got just a mass spread of data, and then
remember with the logger as well, you're decoding at the silicon level, so you are a level above the physical layer, so you're getting this data from the CAN controller. Whereas how we decode, we grab the physical layer, the high-low voltages within the network, and we decode from that. So I guess a test would be to qualify what your logger is obtained as a decode and compare that with your PicoScope decode at the physical layer.
yeah.
Proper logic analyzer, yeah, I hope that helps. That's kind of, I didn't see that question. New level also, does that make it clear that the difference between serial decoder and a logic analyzer? Yeah.
So we don't decode live. A serial decoder does. Bus analyzer does. Yeah.
Rob Harris, maths is cool. You're right. Yeah.
I would count for every time you said that.
It was. I'm just following that.
Oh, okay.
Yeah.
Yeah.
I hope some of that was useful, and I would really like to get back onto that. It's difficult with workload. I would like, the idea or the plan is to do one maths is cool a week. And the more you dig and delve into maths, my word, it takes you on a journey. And so, yeah, that's why Barney's here, because he can now take over to do the really, really clever stuff.
No pressure.
So Ben's just sort of getting a question out to Mickey. So I'm having a read through. Yes, yeah, and I mean that's the other thing. You sort of always use the forum to any feedback on Maths is Cool and Maths channels, and any questions and maybe ways that you would like to evaluate your data, and always fire a question out to us via the forum or support at picotech.com. We're definitely interested in that. So I didn't. So there's
no adapted to add extra channels as you want to.
Okay. Right. No,
It's hardwired based on the frame. So,
Mickey had asked, it's a little bit sort of slightly not off topic as such because it's still PicoScope, so that's what we're talking about. He's got a 2-channel PicoScope, but he was wondering if there was an adapter to make it into 4. But unfortunately, it's the actual hardware inside the box that makes it a 4-channel, so there is no way to move to add extra channels that aren't really there, if that makes sense. So
almost what you want is a scope synchronization, isn't it?
Well, then you need 2 scopes.
Yeah.
But then you could have a 4 and a 2 and have 6 channels.
Right, stop it.
Let me write that down.
Exactly.
Yeah.
Scope sync, Steve.
Scope sync.
That's what we're going to call it. Right.
Cool. Happy days. Not into maths now.
My son's a math teacher. Please ask him to look at Maths is Cool and give us an opinion and contribute as well. That would be great.
I think it was more to do with his son's math teacher.
My son.
Maybe we won't, maybe we won't go any further with that. I think thanks, New Level.
You caught me out there. Big
time. He's got his glasses on as well.
Yeah, that's the problem. I can't. Oh, that's better. I like that.
Cool. Right, how do I raise that? Yeah, likewise.
Walk straight into that one. Walk straight into it. Yeah.
We all need to rewind that. Whoops.
We're sort of, I suppose we've got supposed to be 4 minutes, I suppose, to go. Really?
Yes, guys. Just 2 or 3 minutes left.
If we've got anything else, then share. That's right, Matt.
So definitely fire away if you've got a couple of minutes there, and for any questions.
Yeah.
Okay.
I heard that.
Question there on NVH. Can NVH equipment be used on older model PicoScope or only current version? No, you can use NVH on automotive scopes, older version. So from 3000, yeah, onwards, automotive scope that is, will require a license to use the NVH, so it needs the serial